Okay. So please listen. So based on that previous sum what we have discussed, okay, in exercise 7.2, I think the fifth sum, what is that? 8 sum. So based on that same proof, here we are going to prove that the parallelogram circumscribing a circle is rhombus. So here what we are saying that the parallelogram circumscribing a circle is what it is? Rhombus. Here the parallelogram which it is given. So inside that we will have a circle. So and we have to prove it is a rhombus. Okay. So first here we have to write what are the things it is given. So the same diagram we can consider here. So it's given ABCD is a parallelogram. ABCD is a parallelogram. Okay. So when ABCD is a parallelogram, we are having some conditions for parallelogram. What is the condition for parallelogram? In parallelogram, how the sides will be? Opposite sides are equal and parallel. So we can say that AB is equal to what it is? AB is equal to CD, and then what is that? AD is equal to BC. So opposite sides are equal. Opposite sides are equal. Okay. Any doubt in this? Here, what it will be equal? Opposite sides are equal. And then what we have to prove here? We have to prove that to prove it is a rhombus. It is a rhombus. So rhombus means how the rhombus will be? How the rhombus will be? It is a rhombus means all the sides are equal. So it is a rhombus means we know that all the sides are equal. AB is equal to BC is equal to CD is equal to what it is? CD is equal to BA. This we have to prove. This or no? This we have to prove. Any doubt in this? We understood what we have seen here and what we have to prove. So we have to prove this is a what it is? Rhombus. Okay. The same thing we will be taking here in proof in given rhombus. Sorry, in given parallelogram. ABCD. Here ABCD are external point to the circle. You understand? The same way with tangent theorem, that is AP is equal to AS, PB is equal to PQ, CR is equal to CQ, and DR is equal to DS. Okay? The same way we will be taking the what it is, the tangents. And here what we have done? Adding. The same adding we have to do here. That is AP plus PB plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Any doubt? Okay. Now we know that AP plus PB is what it is? AB and plus CD equal to, we have regrouped AS plus DS and BQ plus CQ. So AS plus DS is AD plus what it becomes? BC. So here we proved till here. Now you see that it's already given. After this, here you can see that it is given. What it is given? It's given that is AB is equal to CD and AB is equal to CD and AD is equal to BC. So we are making only these two changes. Now wherever AB is there, you have to write what it is? CD. Wherever AB is there, you have to write what it is? CD. Therefore, you take this as equation 1. Therefore, substitute in 1, we will get, what is that? Instead of AB, you have to substitute CD. Or else, instead of CD, we can substitute what it is? AB. Anything we can do. So instead of CD, we can substitute AB. Therefore, AB plus AB equal to, here, AD is equal to what it is? BC. AD is equal to what it is? BC. Now, instead of AD, I substitute BC. So, BC plus BC. So, AB plus AB, 2AB. BC plus BC, to BC. Now 2 will get cancelled. Therefore, AB is equal to BC. So we prove that what it is? AB is equal to BC. AB is equal to BC. But already we know that this BC is equal to what? AB. Yes or no? BC is equal to what it is? AB. And then AB is equal to BC means AB will be equal to what it is? BC also. And BC will be equal to what it is? BC also. So anyway, all the sides will be equal. So here we have proved only one adjacent sides are what it is? Equal. Therefore, the remaining all the sides will be equal. Therefore, it is an obvious. Therefore, it is an obvious. You understood? The same proof will take only the changes. We write that by the given what it is a parallelogram. So because of that, AB is equal to CD and AB is equal to BC, we are substituting in the what it is, the first equation. So that time we get the form AB is equal to BC. Therefore, at last you can say that therefore AB is equal to BC equal to CD is equal to DA. You understand? All the sides will be equal. So hence what it is? Hence, can you even understand? Can you even understand or not? Here, why we are writing like that means what is the reason? It's a parallelogram. In parallelogram, opposite sides are equal. Okay, and then by external theorem, what it is? Tangent theorem condition. We'll explain all that. AP is equal to AS, PP is equal to PQ. The same thing what we have done for the previous sum. And we'll be adding all the left hand side and what else? The right hand side. So at last we'll get the form AB plus CD is equal to AD plus BC. Here we'll write that AB is equal to what it is? CD and AD is equal to BC. That when you're substituting in that, we'll get AB is equal to BC. When one side adjacent side is equal means the remaining sides will be equal. Therefore, it is an obvious. That is what hence. Very clear? Any doubt in this? Please. What's the time?